Hello everyone, welcome to this course EE8261 Electrical Circuits Laboratory, and this laboratory is handled by me, and my name is R. Raghuraman, Assistant Professor in the Department of Electrical and Electronics Engineering. Okay, so before getting into the laboratory, let us discuss the course objectives. So the objectives of the course are to simulate various electric circuits using PSpice, MATLAB, eSIM or Skylab. Basically these are certain simulation softwares. So out of these simulation softwares, I recommend MATLAB to carry out this laboratory. See, because this MATLAB finds extensive applications for electrical engineers, and you people in the forthcoming years will see a definite impact of the applications of MATLAB in the areas of your power electronics and power systems as well. Also, if you are getting familiarized with this MATLAB, you can carry out your final year project, your undergraduate project, as well as when you go for masters or for your research purpose. This MATLAB software will be very useful. Since I want you to get familiarized right from this first year, I am recommending MATLAB, and we are going to work on this MATLAB throughout this course. And another point is, the objective of this laboratory course is obviously we need to get some practical experience on electric circuits, and we are going to verify the theorems. What are the theorems which we have came across in our electrical in our theory subjects? We are going to verify those theorems practically as well in this laboratory course. So the syllabus consists of these are the 11 list of experiments. The experiments are listed out here, and for this laboratory point of view, I have just combined certain experiments, and this is the experiments I am going to introduce. So in this laboratory you have 10 experiments that covers the entire syllabus. Okay, and you could see this laboratory syllabus is very much in line with your theoretical subjects that you have read recently. So this is your subject, this is your syllabus for your theory subject that you have come across, and this is the laboratory syllabus. So what are the things that you have studied or you have understood in your theory subject? You are going to work out the same and verify it practically. Okay, so as I told you, this laboratory, all these have two parts. You could see verification of Kirchhoff's voltage laws and current law, and simulation of Kirchhoff's voltage law and current law, which means you are going to practically verify all these things in the laboratory. At the same time, you will be verifying it in a simulation software, that is MATLAB. So in this, initially first we will cover all the simulation part. Okay, and the purpose of simulation. Why you need to go for simulation? See, there are a lot of purpose for simulation. As a beginner, you may not know how exactly to connect the components. In case of any wrong connections, it may eventually end up in damaging the equipments, devices, or it even may cause harm to you. So to avoid those things, in order to get better understanding of how these devices and components work before experimenting it practically, we have a concept called simulation. So the advantages of simulations are plenty, like there is no physical components involved. Even if you would give some wrong connections, you may not it may not be very hazardous. Also, it is very cost effective. You can vary the components range. You need not go to the market and purchase different components, and you need to connect. You can analyze their performances through some software packages, that is by simulating. See, in this image also you could see a person is trying to drive a flight, right? He is learning to pilot a flight. So he is doing it with some emulator, some simulator kind of thing, because see, even if he does some wrong judgments, it is not going to bother, it is not going to lead to any dangerous results. So he is learning the flight driving through simulators. And you could see similarly here you could see a person is learning to drive a car through a simulation first. So as a beginner, it is always a good practice to understand the concepts through a simulation rather getting into hands-on experience practically, because even if you make any mistakes, it will not going to cost you much. Okay, on the other hand, and for this simulation, I've told you we are going to use a device called we are going to use a software package called MATLAB. MATLAB stands for Matrix Laboratory, and here the components like resistors, inductors, diodes, all the components will be mathematically modeled in terms of equations, like mathematical equations, differential equations, and it is going to exactly replicate the behavior of how your resistor or inductor works. Okay, so in this laboratory, what you are going to do, we'll just see. So generally throughout this course, all these 11 experience of all these for all these 11 experiments, you will be given a circuit on hand. So for that circuit, you need to perform a manual calculation, like for this particular voltage, what will be the currents through various branches and voltage drop across various elements. You need to perform it manually, like you need to do manual calculation. See, these portions we have come across with these things you can do with the help of your subject knowledge, and that then before verifying the theorems, you need to predict the behavior of the circuit. See, given a circuit on hand, you need to know how the circuit is going to behave. So now the next step is you will be simulating it with the MATLAB software, and you will be verifying it with your manual calculation. What are the things you have drawn manually? You will be verifying it with the simulation software whether you are arriving those things. And the next step is you can go for circuit design. Now you are confident, now you are able to predict the circuit and you have verified it with the software simulation. And the next part is you can go to the laboratory and you can connect the circuits and you can confidently verify the results. So these are the steps that you are going to follow throughout in this laboratory course. Okay, let me right away get into the first experiment. So verification of Kirchhoff's voltage law and current laws. Okay, you know what is Kirchhoff's voltage law and what is Kirchhoff's current law. Okay, you know the statements, right? So the aim of the experiment is to verify them both theoretically and practically for a given circuit. The circuit may be any circuit. Okay, for this experiment we have taken a circuit like this. So for this circuit, I need to verify both KVL and KCL. And so here 0 to 30 stands for you can vary the voltage between 0 volt and 30 volt. So this is a variable voltage. You can vary the source voltage and you can verify the KVL and KCL. Okay, you have the resistances of R1, R2 and R3. So first let me recollect the theorems. So by KVL, what KVL states it? The sum of potential drops is equal to the sum of potential rises in a closed circuit, or the algebraic sum of potential rises and potential drop will add up to 0 in a closed circuit. Okay, so how to measure those voltages? So practically to measure those voltages, you need to connect a voltmeter in parallel to the point which you are in parallel to 2 points across which you want to observe a voltage. Basically, voltage is a potential difference between 2 points. Say if I want to measure the potential difference between this point and this point, that is the voltage across this resistor, I need to connect a voltmeter across this resistor in order to measure the voltage. Similarly, these two resistors are in parallel. We know in parallel the voltage is going to be same. So I need to connect another voltmeter in order to measure the voltage across this R2 and R3. And to measure the supply voltage, I need to connect another voltmeter. And what is KCL? By KCL, if I consider this as a node, the algebraic sum of currents entering a node is equal to the currents leaving the node, or the algebraic sum of currents at any node is 0. So say if I consider this current as I1, this I1 should be equal to this I2 and this I3. This is what KCL states. So I need to verify these two theorems for this given circuit. Okay, first let us perform a manual calculation. To perform a manual calculation, Before that, let us first try to understand it, how you are going to practically verify it. So in order to practically verify it, I need to measure the currents at this branch and these two I2 and I3 branches. For this I need a ammeters and always remember currents are measured with the help of an instrument called ammeters, and these ammeters should be connected in series. And this to measure voltages we have voltmeter, and this voltmeter should be connected in parallel across the points. Okay, so for this circuit now you need to draw a practical circuit for the given circuit. How to draw the practical circuit means you have to incorporate those meters at appropriate places. See, this 0 to 30 stands for this is a variable source, that is a regulated power supply. RPS stands for a regulated power supply, which means with the help of this variable power supply you can vary the input voltage anywhere between 0 to 30 volts. And as I told you, you need to measure the currents through this branch, right? So this is done with the help of ammeter 1, that is here you could see I1, and you are measuring the currents I2 and I3. See, these ranges of the meters you could come to know only when you perform a manual calculation. Okay, for the highest voltage, if you set voltage as 30 and you could, when you observe the currents and voltages, then you can come up with the instrument ratings. Here you have chosen 0 to 10 milliamps because I know pretty sure the current in the circuit is going to be less than 10 amps, 10 milliamps. And as I told you, to measure the voltages, basically I need to connect a voltmeter across this point to measure the supply voltage. But this RPS, it comes with a indication where you can visually see the set voltage. You will be having a display, you will be having an inbuilt display which will be showing the set voltage. Okay, so you need not have this voltmeter V. So you are going to measure this this you are taking as V1. Obviously this V1 should be equal to the voltage drops V2 and V3, or V1 plus V2 plus V3 should be equal to 0, that is KVL. And your KCL is this ammeter current I1 should be equal to I2 plus I3. Then you need to tabulate the results. You have to tabulate your observations. Say for example, you need to, as I told you, you can vary the voltages, right? So you can just a minute, yeah. So you can set voltages as 5, 10, 15, 20, 25 and 30, and you can measure the corresponding voltages and the corresponding circuits, and you can tabulate them. So this is what you are going to basically do. Before that, as I told you, you need to perform a manual calculation, right? So to perform manual calculations, you can take any readings. Say in this case, let me take voltage as 25 volt. So if I set 25 volt, let me find what is V2 and V3. Okay, so let us perform manual calculation for this. So for this circuit, now I am going to perform manual calculation for a given voltage of 25 volts. Okay, so see, I am going to set V1 is equal to 25. Now for this 25 volt, I need to find what is the current in the circuit, right? So my circuit now will be like this. Okay, so this is I'm going to keep it as 25. This is 1k, and this is 1k, and this is 1k. So I can parallel these two 1k's. So it is going to be 0.5k, and this 0.5k will be in series with this 1k. So it is basically going to be 1.5k. So my current is going to be, total current is going to be V by R, which is 25 divided by, what is the total resistance? 1k in parallel, you will be getting 0.5. so it is in series with another 1k, so it is going to be 1.5k. So the current is 25 divided by 1.5. It is going to be 16.67 milliamps. So that is the total current in the circuit, 16.67 milliampere. So I know the total current. I can find the drop across this resistor. It is going to be 16. I can find the drop across this V2. So my V1 is 25 volts I have set. So V2 is going to be, since it is a series circuit, the current is going to remain same here, and 16.7 is going to flow here. So 16.67 milliamp into 1K, which is going to be 16.67 volts. And what is V3? So V3 is the parallel combination of these two voltages, right? So V3 is the parallel combination of those two voltage resistances into current. So 0.5K into 16.67 into 0.5, it is 8.335. So now you can apply KVL. What is KVL? By KVL, you know V1 is equal to, should be equal to V2 plus V3. So your V1 is 25 and your V2 is 16.67, 8.335. So if you verify, this will be 25, and you can say hence KVL is verified. Now coming to the next portion, that is KCL. You need to verify the KCL, right? Okay. In order to verify the KCL, see, this was the circuit in my hand. I have a 25 volt source here, and I have a 1K resistor, and I have another parallel branch like this. All was 1K. Okay. I am having 16.67 current milliampere was flowing here, right? So this is my I1. So by KCL, what according to this circuit, this is I1, this is I2, and this is I3. So if you apply KCL at this node, I can write I1 is equal to I2 plus I3. Okay. So basically the 16.67 is getting divided here, right? So you can you can use current division to find the current through these two branches. So if you put current division, or since these two resistors are in parallel, you can exactly say the current through I2. I2 is nothing but 16.67 by 2. That is, the current is exactly dividing. Okay, so 16.67 divided by 2, so which is 8.335. And you could see I3 also, it is going to be 8.335 milliampere. So I can say the current coming here at this node is getting divided into I2 and I3. So you can say, see, this is 16.67 milliampere, it is getting divided as 8.835 milliampere and 8.835 milliampere. So if you add this, your KCL is verified. Okay, now let us go into the simulation portion. So this is the MATLAB that I have opened here. This is MATLAB 2021. This is the latest version I am using, and if you want this MATLAB software, please reach out to me. And in fact, our college is providing a campus license. We do have a license for this software, so you can reach out to me. Okay. So this is basically the command window. Through this window only, the MATLAB communicates to you. The MATLAB throws error messages here, will show you the output of your program here. So this is basically the window through which MATLAB communicates with you. And in this simulation, basically we are going to draw the circuits. Like we will be internally, the circuits have been modeled with the help of differential equations. So you have a resistor, you know how the resistor works. The behavior of the resistor is through equations, it has been modeled and it has been available as a block. All you need to do is you need to pick that block, just drag and drop it, and you need to form blocks, and you need to connect it, and you need to eventually see the output. Okay, so we are going to use Simulink. Simulink is a tool where you are going to where you are going to make use of the available blocks, and you will be simulating the circuit. So you can just choose here new Simulink model. This is the place where you are going to model the circuit, or you can straight away click Simulink that is available here also. So here you just give blank model. So you could see a blank model has been created under the name untitled. So you need to just choose the components, just drag it and drop here. Okay, so all the models, all your components are available inside this block called library browser. So under this menu, browser menu, library browser, all your blocks are available. So you have to tap this library browser. See, this MATLAB is not only used by electrical engineers, it is used by everyone. So you have your many aerospace toolbox, your automated tool, your communication toolbox, your data acquisition toolbox, your digital signal processing toolbox. See, it is not only used by electrical engineers, it is used by many engineers. And since we electrical engineers use this, our components will be available in the category called Simscape. Okay, so you have to expand the Simscape. Under, you carefully observe this, you have to expand this Simscape. Under Simscape you have to choose electrical. Okay, and under electrical you have to go for specialized power systems. So all our blocks are available here. Okay, to draw the circuit, see what is the circuit that is given on our hand. The circuit that is given on our hand is, this is the circuit. You are having a voltage source, that is a DC voltage source, 3 resistances, and the measuring instruments, ammeters and voltmeters. So all these components are available under the library browser menu. Okay, so you see, I'll open this library browser menu. Okay, and this is the untitled page available here, and you could see we are inside, where you carefully observe, we are inside electrical, we are inside Simscape. Under Simscape we are in the electrical and specialized power systems. See, Simscape, electrical, specialized power systems. See, the first thing you need to drag and drop is this power GUI. This, without this power GUI your model will not work, because this power GUI contains all the libraries that are essential for the power system circuit modeling. Say for example, you will be using for C program hash include stdio.h, conio.h, some header files you will be using, right? So likewise, this is you can assume it as a kind of power supply. See, this power GUI block is the primary block that is essential for all your electrical simulations, electrical circuit simulations. So you first click it, drag and drop it, or otherwise you can just right click and you can give add block to the model. These are the two ways of picking a block from the library browser menu into your model. Okay, next I told you you need sources, right? So go to sources. I need a DC source. See, DC voltage source. You just click once, drag and drop it here. You could see the DC source is getting added to your model. Next you need resistances, right? So you go to again library browser, you find you go to a block, you go to specialized power systems, and you go to passives, that is where your resistors, everything available. You just choose series RLC branch. You can just double click it, or you can drag it and drop it. So I am just dragging it and drop it. Okay, I am just dragging it, sorry, I am just dragging it and dropping it. I need how many resistance? 3 resistance. Before that, this is a series branch. You need to convert it into a resistor. So you double click it, you tap it, you twice. So you just convert this branch type. This is the block parameters. When you double click it, a block parameter dialog box will open. So you need to choose the branch type as resistance, and you can give the value as 1000 ohms, because that was a 1k resistor value shown in the circuit. You just I need 3 resistance. You can just copy it and paste it, right? So you need not go to the library browser again and take it from there. You can either do that, or simply you can right click it, drag and drop it. Once you right click and drop, that is equivalent to a copy paste operation. See, I am just right clicking it once. You could see a copy here. I am copying it, and you can give here, right click again, and you can give paste. So you could see another resistor block is being duplicated. So one way of copying and pasting is right clicking it, dragging and dropping it. Okay. Next you need measurements, right? You need your ammeters and voltmeters. You need not give the value of those resistance again. See, if you double click it, the value is 1000. That is what you want, right? You need resistance of 1000 ohms. So the values are right. And the voltage source you are going to set as 25 volts. Okay. Then you know you are going to pick what? Your ammeters and voltmeters. So go to measurements. You go to sensors and measurements. Take a current measurement and voltage measurement. See, I am taking a voltage measurement, clicking it once, left clicking it, and dragging and dropping it. See, I need 3 voltmeters, one to measure the source voltage, and I have and to measure the drop across this resistor and the drop across this parallel branch. So I have duplicated 2 more voltage measurements. Then I need current measurement, right? So see where it is available, Simscape, everything is available under electrical power system. See, I am searching for a current measurement. It is available right at the top. So I am right clicking it. I am just giving add block to the model. You could see a current measurement block has been added. So you have to, you know that your current measurement should be connected in series. I need to measure this branch current and this branch current. Okay. Now you can once all your series components are available, you can close the circuit, right? So from the I'll just show you the circuit once. Before closing it, I'll show you the circuit. So this is the circuit I need to connect. I have 3 ammeters, right? Series branch. See, I have a voltage source connected to an ammeter connected to a resistor, and this resistor is connected to this parallel combination. Again, I have ammeters at both the branches, and at last I am closing the circuit. See, I am having see, this is my supply voltage. I am connecting it to the ammeter. See, just a minute. I have connected it. The negative portion you have to connect it to the resistor, and this resistance is connected here, and you know this is going to be a series branch. You could even connect it like this fashion if you like it. Then you are having this resistance connection here. Then you have to connect this ammeter to this branch. These both ammeters are connected like this. Then you can close this circuit. So this series portion has been closed, right? Then you have to connect the voltmeter. One voltmeter is to be connected across this source, that is V1. This voltmeter you need to connect across this resistor, right? So you need to rotate this voltmeter if you for better clarity. So you just click it here. You just give Control R for rotation purpose. You could see it is getting rotated, right? You could see it is getting rotated. So give Control R for rotations. Okay. Another way to rotate is you just right click it, and you could see an option called rotate or flip. See, rotate and flip. You can either rotate clockwise or counterclockwise. So I am connecting this voltmeter parallel to this branch, right? So this plus I will connect it here, and this minus I will connect it here, and now I need to see the value of those readings, right? What is the reading of the voltmeter, what is the reading of the ammeter. Practical ammeters and voltmeters have a dial display overhead it. So now I need to search for a display block. See, these display blocks are common blocks, right? So go to the library browser, you scroll to top, you could see a block called sources, sinks sources, right? You go to sinks, under sinks you just choose display. How many displays I want? See, for all those measuring instruments you need displays, right? Measuring blocks. So for this voltage measurement I am just connecting this. So I need not go back again. I can just right click it, drag and drop it, so that I can duplicate one more display. Likewise, you duplicate the displays that are essential. How to duplicate it? Just right click it, drag and drop it, for it is equivalent to your copy paste operation. See, once you have connected all these circuits, just verify their parameters. This DC source, the value is 25 volts I have given, and now as per we need to verify whether it is matching our manual calculations, right? Okay, so I think we have drawn all the circuit completely. Now this is the simulation time. For how many seconds you want to simulate the circuit? Let it be 10 seconds, no issues. So once your circuit is over, you can then and there you can save the circuit also. So let me save the circuit. I am just giving KCL and KVL. Okay. You could not you cannot use ampersand and symbol in between it, so you could it is throwing a error. So you can just remove this and you can use an underscore. So you could see the block has been renamed to KCL and KVL. Okay. Once your circuit has been saved, you can do simulation. You can give simulation by pressing this green color button, run, right? You could see the play button. So if you press this, the circuit will simulate. Your circuit will start simulating. This model will get simulated. See, you could see I have given run. You could see the circuit is the circuit will get simulating. Please wait. See, you could please observe this. It is 2% simulation is over. See, you could see a green you could see a block compiling, right? See, it will first compile. If any blocks has not been connected or any blocks have been connected wrongly, it will display error message. If everything is right, your compile will get success, and you could see this model will get simulated. So since it is the first time we are running it, it is a bit slow, so the circuit is getting compiled. See, the circuit is getting compiled. You could see a taskbar that is filling in green, right? So you can also see now the circuit has presently the circuit is running. You could see the simulation time, right? It is t 0.00 seconds. That is your 0% simulation has been completed, and you are simulating the circuit for 10 seconds, right? See, by mistake I have paused it, sorry. See, now 100% simulation has been completed. Now you see the input voltage is 25. You see the current, it is 0.0167, that is 16.67 milliamps. I'll just zoom this for your, sorry, I'll just see, this is 16.67. See, this is 16.67 volts. This is 8.33 milliamps. This is also 8.33 milliamps. We have forgot to put a display for this meter also. I'll again run the circuit. See, I have made a change and I need to save this and run. It is showing star because I have not saved the changes. So you save it, then you run it. Okay, so you could see the KVL. See, the 25 volt, this is 16.67 millivolt, sorry, this is 16.67 milliamps, and this is 8.33 milliamps, 8.33 milliamps. So your KCL is verified. Your 16.67 milliamps is getting divided into 8.33 milliamps and 8.33 milliamps. Likewise, if you see voltage, it is 25 volt. Here the supply voltage 25, the raise is equivalent to 16.67 drop here, and the drop across this parallel branch is 8.33. Thus KCL and KVL have been verified. So if you want, I will just zoom it and I will show also. See, you could see the block readings. It is 0.01667 means 16.67 milliamps. This is the your current measurement, right? And you see the voltage measurement is this is the supply voltage 25, and this is the voltage across your resistor is 16.67 volts. So this is the way of verifying the KVL and KCL through simulations. Basically, we have drawn the circuit. I again repeat, right? All our components are available under Simscape category, special electrical and specialized power systems. So if you want to reset your zoom, you can give you can just give simply reset, right? See, this is auto zoom. Okay, this is fit to view. So this is the model that we have simulated. I again repeat, just remember this power GUI block is very essential. Without this block, see, if I delete this block and run, it may throw an error. Okay, see, it is throwing error. It is unable to recognize this measurement, current measurements block. So you need power GUI block is essential. So when you try to run a model, after compiling itself, it will throw an error. Okay, or you can read out this error and you can sort out. See, this block should be named, the diagram must contain a power GUI block. It is even giving you the reason. So immediately you can go to library browser. All our components are available in under Simscape. Under Simscape, where electrical, under electrical, sorry, Simscape, just a minute, Simscape specialized power systems, right? Electrical, under this electrical you have to go for specialized power system. Under specialized power system you have power GUI. Okay, once if your power GUI block is there, your model will run fine. Okay, so this is how you need to verify KVL, and you can even verify it for another set of voltage also if you wish. So you can just double click this parameter and you can vary this input voltage to 30 volt, and you can again run the model. See, I have changed to 30 volt and I am running the model. See, the model is compiled and it has been run. See, the 30 volt, the total circuit current is 0.02 ampere. It is getting divided into 0.01 and 0.01 amperes, and you could see the voltage 30 volt has been dropped as 20 volts here and 10 volt across this resistor. Thus KCL and KVL are simply verified through this simulation. So with this, the first experiment is getting over. The simulation part of the first experiment is over, and I'm stop here. Thank you.